Friends, welcome again. My name is Samuel Kamochu. I know some of you already know me. And I'm here to take you through part of what you're supposed to study in this week. And I'll focus today on databases. And even before I start, I'd like to state that I have worked with a few databases in the last few years or many years, depending on how you look at it. And my hope is that today I'll share whatever that I've seen or that I have applied in the operations of the many systems that we run. So there are a few things I am hoping to give you a picture of the things that you should not forget. You're not going to get everything here, but at least you'll get an overview of the things that you need to know. And I hope that the session will be helpful to you. So as part of what we had indicated as the task for this week is you're supposed to appreciate SQL databases, NoSQL databases, database models and ER diagrams, ORM, object relationship mapping. Then there is migrations in the DB, connecting to databases. You need to know how to connect to databases, either directly using a terminal or using a tool or using your application when your system needs to record or insert a record into a table or into a collection. Then you need to know how to do it. The other elements that you also need to appreciate: indexing and partitioning. So I have prepared some notes for this session, and I'm hoping that by the end of the session, you'll have gotten a grasp of some of the concepts that I've mentioned. And I'll also try to be as practical as possible so that we can have a good session. So what I will look at is I'll start by defining the database. And the thing is, before we talk about database, you need to appreciate what data is. Allow me to just increase my screen a bit so that some of you don't read too many lines. But data can be facts related to an object in consideration. E.g., if you're considering a person, the name, height, age, or those could be the parameters that you need to consider, or the facts that you need to consider. If you're talking about your bank account, then you know what facts you need to know about or to consider about that object. So this is the context of computer systems. So if you are recording the data somewhere in a physical paper or notebook, this is not the data we are talking about. It's about data that is recorded in a computer. Now, databases is basically a systematic way of collecting data. I know some of you call MySQL database. It's not a database. The database is actually the data that you organize in a systematic way. So if MySQL is not a database, then what is it? If Oracle is not a database, then what is it? I know we use it loosely many times, but a database is actually that collection of your data that you have collected. If you're talking of a problem domain like a school, then you can decide to organize your data in a certain way. So normally we can use certain terminologies. Sometimes we say tables. So you can think of the data being organized in tables. So you can think of an Excel where there is a column that has a heading, and there are rows that represent the data. Kabi, maybe you can mute a bit. Okay. Thank you. So let me just go back and say that when you're organizing the data, you could think of how you put data in an Excel. Rows contain the data, and the first row contains the heading or the headers. So if you say that you have a file that in the first row, or maybe you have a standard headers for each of the parameter, and you have separators, in this case, a pipe, which is our separator. So the first data item is 1001, which represents the admin number, the name, and this, and this, and this, and this. All this information is captured in the file. So if you have a file called students.txt, and you have this data stored like this, and you know once you split, each and every part represents a certain element of data, then you have a database. So if you organize your files within a folder in a certain folder structure, you have a database, as long as it's systematic to allow someone to retrieve the records that they need. Now, I will also illustrate the same with teachers. So this is within the domain of a school. So you can have the staff number, the name, the teacher's name, that is the ID number, the date of birth, TSC number, home county, and the join date. So this is data that you're storing in a structured way, and it's in a systematic way. So if you have files in a folder and you have the students.txt, teachers.txt, classes.txt, you essentially have a database. So I just wanted to demystify that, because many people call databases they refer to databases and they think of Oracle. A database is actually the folder that contains the data, the files that are structured in a certain way that allows you to add, update, or query easily. So I hope there is no one who has who has a question on that. And I'll move to collections, another way of representing data. So you could have a file within the computer and you call it student.json. For those of you who have studied JSON, I think I introduced to you guys, this is a valid JSON request, and you can see how each and every value is stored in ID and key value, key value, key value, key value. Now, this is also something I would call a collection of objects, and each object is represented as a JSON object. And this is also a database for us. So do not confuse what you have. Now, when we are having all this data, we store it in a computer in a certain way. From my experience, whether you are dealing with Oracle that manages databases, all these systems, they all store data on the disk. At least I've not used a database management system that doesn't utilize the disks to store the data. So you need to remember that although you create a DB, you insert a record, you do anything that you do, you must always remember that there is somewhere the data is being saved in the disk. And I know these are some of the things that you take for granted. My work here is to help you appreciate, because now once you understand that, then it makes certain conversations become easier. So whether you're using tables or collections, they are represented as files on disk. This means that for every collection or table, you'll find a corresponding file or files on the disk. And sometimes, depending on the system that the database management system that you're using, rules could vary. You could find that maybe there is a certain engine that stores everything into one file, but you still have files. Some separate certain things into a table is a file. And others might decide that a number of tables will store data into one file. That is the decision of the guy called the DBMS. So database management system is another software that interacts with that data for the sake of storage, if you want to store something, retrieval, and updating of data in the computer system. So Oracle is a DBMS, MySQL is a DBMS, or Mysql, depending on how you want to read it. MongoDB is a DBMS. And all these things are softwares that allow us to handle management of the data on the disk. So then you also need to realize that we have SQL and no SQL databases. Today, I'll not talk about databases, sorry for the typo. These databases, you'll have to go read about them. But the basic concept is the illustration I gave here. This is how probably data would be stored in an NoSQL DB, where we are very loose on the structure, while relational SQL-based databases, they are very hard on the structure. So if you want to add another column here, you must change, and every record must have that column. You'd rather have null, but every record must have the same number of columns. In NoSQL, you can have a student here with another attribute that is not in the other attribute, And you can go read more about it. But one of the differences is that one is very hard on structure, strict structure, and the other one is very easy and flexible, just like we are in this dispensation of being agile. So that's why you hear today NoSQL databases are more popular, because SQL, they're more popular with, these flashy systems that we use, because they don't have a lot of headaches of ensuring that, you do database updates every now and then. Once you add a column, you have to go and now alter the table. So sometimes in NoSQL databases, those things do not exist, but I don't want to dive deeper into it. Now, the naming of tables, or maybe sometimes when you're creating a database, you can create a database, and inside the database, you can create tables. Now, I'm speaking in terms of SQL databases. They are the ones that use the concept of tables. Sometimes you might hear a database schema. Don't get confused. It's just a collection of objects that are related. So you can create tables, and tables is one of the objects that you can store in a database. So you store data in the context of tables. And the key idea is that some people argue, how do we name tables? And I wanted to highlight this because as you work on your projects, you'll get to a point where you decide to agree on a naming convention. There are people who argue, should we name a table if you're storing students? Should the table be students in plural, or should it be student in singular? And my answer is, guys have debated this. There is no consensus. And it depends on what you agree, but irrespective of what you agree, you must be consistent. So don't call one table students and the other one you call class. Student, teacher. You have to say student, students, teachers, classes. So you have to be consistent in whichever approach that you use. So in my view, because a database stores more than just tables, sometimes you store stored procedures, you store functions, you store triggers, you store indexes, all those things together when they are collected and they are within one systematic grouping, that's what we call the database. So you can decide to have prefixes, like for me, what we do, and in our organization, we decide that objects, entity objects, if you're defining a class within Java that you're supposed to save into a DB table, we use singular. Because you don't say students is equals to new student, or student A is equals to new students. So it sounds wrong to call an object students. So the object itself is called student, but our tables, we give them plural, and we add a prefix to say maybe TBL students. The TBL indicates that it's a table. So in case you're dealing with functions, probably you'll have FN underscore something. If you're dealing with stored procedures, you'll have SP underscore something. So that tells you that within a database, which you're saying it's a systematic collection of data, and it has objects inside it. Those objects, mostly we know tables or collections, but there are other objects that are also part of the database. And all those together, you manage them through a DB management system or DBMS, and that's why Oracle or the other guys come in. I don't know whether there is anyone with a question up to there before I dive deeper into the DBMSs briefly, and then I can do a live demo of some of these concepts and illustrate the concepts that I'm mentioning here. Yeah, so don't confuse data, database, and now you have database management systems, and we are talking about tables because they are the central of databases, and it's important that you know. So I'll proceed to the next step where I talk about database management systems briefly. So I have already said that database management system is a software that handles the storage, retrieval, and updating of the data within a database in a computer system. So DBMSs that we have is MySQL or MySQL, MongoDB, Oracle. Blame my teacher when you hear me saying MySQL. Apache, Cassandra, Postgre, and or Postgres. And the key thing that you need to know is that all these databases, database management systems, you can choose whichever. The only difference is that the SQL databases, they use SQL, insert, update, and delete, and it's sort of standard, although you find a bit of variation when you move from Oracle to other DB. So you'll find some few differences, but generally the structure is the same. And I would like to mention a few things before I now go and log it into the server. One of the things that I'd like to mention is that though the data is in the disk, we do not modify the data manually using a text editor. I know I had given you an impression that if you create files, JSON student.json, that data, you can call it a database. And the assumption is that you could modify it. No, in database systems, you do not modify manually. You modify it through another system. In case you need to add, update, delete, or some data, the request is sent through the software, the DBMS, that does the magic of updating the files on the disk accordingly. So most DBMSs support communication via network. And I know some of you by now know that when you're talking about networks, a server must have an IP address and they run as a service. So they have a process ID on the OS and they expose a port. And this is conversation that I'm hoping is not confusing anyone. So you'll find that MySQL or MySQL uses a default port of 3306. If you install and don't change the configurations, the port is 3306. MongoDB, the same, has its own port, 27017. So those guys who are asking questions about ports yesterday, you can see it's just the developers who decide. But you can see that these services that were created by private institutions, they all go above 1023 because we all agreed that 0 to 1023 ports are reserved for well-known services or well-known ports. Yeah, so Cassandra is 9042 and the other one is 5432. For security and optimization reasons, some of the DBMSs, although I have given you an impression that data is in disk, if you go and try to open that file, because I'll show you the file of a table that has been created, you cannot view it because it is in binary. And I know by now some of you might not be confused by the word binary. Binary means that it's in ones and zeros. It's not text-based files. It's like the way you open a Word document. If you open it with a notepad, you might not enhanced notepad, but or even you open a PDF, or you open an installation file, a .exe on Windows using notepad. Those files are binary, and there is nothing much you can make sense of if you open with a text editor. So I will go to MySQL and I'll use MySQL to demonstrate these concepts that I have talked about here. And I will show you some few commands that you need to know. Please take note that although I'm using MySQL, the equivalent of whatever we are doing is available in all the DBMSs. And for now, I'm going to go to my Linux, my terminal, and I will just increase it a bit, and I will do that. Some of you who were there yesterday or the day before, you noticed that probably I had created a script called Natujenga shell scripting, which we will cover in another session if you guys are interested, so that you don't start typing commands in full. Now I'm inside the server. If you note, I'm actually inside the server. This was my terminal that was on my local machine. And now this is the terminal and you can see the different bash. If you're not so sure, I can exit and you confirm that PWD, I'm actually in my local machine, which I can do here, echo shell. For those of you who are there during you can see I'm using Z shell. So then I can actually log into this machine. Now I'm moving from Mac OS to Linux. I've logged in. If I do echo shell, you'll note that I'm using bin bash, which is the default for our OS that we're using. So I'll clear so that I go back to the top. Now, one of the key things that we said is that on this server, we installed MySQL, and I will not repeat the installation of the MySQL commands. So we already did the installation yesterday. So I'll just show you this to show that the service is running. And I will also use other commands that we learned yesterday. I can actually also do MySQLD to see that there is a process that is actually running. And you can see the process is 80. If you want to know whether the port is open, I can use another command that we learned yesterday, .0.0.1. This is on the host machine, and the port will be 3306. And if I do that, then you can see that I'm actually inside. And I can quit. So essentially, we can confirm that our service is running. So of course, this command, you can change stop status, you can put stop, start, and all those things will be there. But now the question is, how do you log in into the server using command line? How do you log in into the database? So I'm going to log in into the database, and I will come here and I use MySQL command. Ideally, if you install MySQL and it is not secure, we didn't secure this MySQL, the default username of the DB is root, and the password is an empty space. So normally when you want to log in into a DB, you can say MySQL, it's the command. This MySQL command only works if you have installed MySQL on that server. And I can just minimize these a bit. And I'm going here to just say MySQL minus you, the user. You can say root. If you have created another username in the DB, you can use it. You don't need to have a space. Whether you put minus u space root, minus u no space root, it will work. Then you can say minus password if you want to ensure that you put the password. And at the end of it all, you can specify if you want to log into a specific DB, you can say DB name. Now, once you log in, it means that you have logged in and selected the DB that you're going to use. Or basically, you've connected to the DB service, the DBMS, and you're now inside a certain DB. But for us, I'm going to just illustrate this command. Now, I'll show you something else. If you want to log in, so if I log in without all those details, I'll get in, and you can see that I have logged into this machine, so I can exit. But I want to illustrate that I can also log in, and I specify the host. If you want to log into a remote server, and I know you guys will do this because you'll be running your databases as containers on this server, and then you can say port, and you say 3306. That means now you are logging into a remote server. It's only that 127 is not remote. It's actually this host. It's local host. Then I can do minus u root, and you can do minus p for your password. So ideally, this is a command that you should remember. And if you enter your password, for now, it's an empty space. I already getting into the DB. Now, one of the things that you're going to do, check-in status, I will not repeat this because we did it yesterday. So we are not going to talk about that. So I'll go and show you some few commands that are very critical. If you learn this command in MySQL, you can find the equivalent in MongoDB. So one of the things that you need to know is that you can do show databases. And you can see the databases that are there. And I want to show you guys, yesterday we talked about that MySQL has a configuration. I've told you here that every database stores data into the disk. Now, the data path for MySQL, if you want to know it, you go to etc.my.conf. That's where the configuration file. Now, my.conf tells you that you go to etc.my.conf.d, and then let's see MySQL server. And this is the configuration. Oh, sorry, I needed to do cat. I want to view the file. So cat is the command for just printing the content of a text file. Don't do cat in a binary file. One of the things you'll notice that MySQLD, the daemon that is running, stores the data where? In this data path. So if you want to come and change the server settings, this is where you come and change. So for us, we're going to come here, and I will change directory, and I will clear. Then I will come and do ls minus ltr, and I'm going to have this data here. Now, one of the things that you'll note is that there are folders that are here, that are already in this DB. And what I'm going to do is I'll come here and I'll open a new tab so that I have two tabs. I hope I won't confuse someone. And I log into Natujenge so that here I am on shell. And on this side, I am on the DB itself. So here I log into the DB. I don't know whether history will show me the command for logging into the DB. Okay, I can see some guys have already started doing some stuff, but let me just do MySQL. I log into the DB, show databases. I know some of you have already created the databases. Those who haven't, you are lucky that I'm doing this because you'll be able to see this. So I'm inside the database. So one of the things that I'll do is I'll assume we are creating a system for messaging. I will create a DB called messaging. And how do you create a database? You create a database called messaging. And if I create a database called messaging, when I come here, because I know you guys now understand the ls command, if I come here and I just, or maybe I can just do ls, you can see these folders. The folders are in blue. Some of you can already confirm that there is no folder called databases. So if I come here and create a database called messaging, I can come here and do ls again. And guess what? We can see the folder called messaging. This confirms the narrative that DBMS is, which is MySQL. When you write these statements, it actually translates into organizing the data in a systematic way on the disk. Now, one of the commands that you use, and if I show here, show databases, these are commands that we use on a day-to-day basis, and you can see messaging is there. How do I get into that database? So you say use the database name, and our database name is called messaging. Now, if I get in there and I log in, I change folder to messaging, and I look at what is inside there, the folder is empty. So I'm going to create a table. I'm going to create a DB table, and I will create a DB table. I hope some of you already know how to create tables. So I can come here and say create table, and then I give it TBL SMSs because it's a messaging system. So I'll do create table in MySQL. That's how you create a table. Then you call it TBL SMSs. I will call, or I can call it TBL messages so that I don't confuse you guys. And then I can say ID int, maybe 11. I don't know whether it's integer. I think it's integer 11. I need to confirm that. So I have int, then I can say integer, and then I put 11. And then I can come here and say this is a primary key. I know some of you have heard about primary keys. And then I can come and say the MSSDN. Your mobile number is called MSSDN, and var variable characters of about 20. We are assuming that numbers. And then you have the message that you want to send, or you can call it the content that you want to send. And the content maybe is it's var. And then you can have 500. I hope you guys can see my screen. And then you can say created on, and then you can come and say date time. And then you can say updated on. You can see my screen. I forgot one comma, but it's okay. Then I can come here and say status. I can say int. I can do 11. And I can close that. I can do that. Of course, it will give me an error because I did something wrong there. So allow me to just come here and create a new file. And I can get rid of this. Oh, give me for and then I can do a comma there. So I'm creating a table. And I hope now it works. Yes, it works. So if I come here and I look at the folder now, you can see tbl messages.id. So this confirms the narrative that DBs store data into the disk. Once you appreciate this, there is a lot that will make a lot of sense. Now, because DBs store data into the disk, if you insert, data will be stored in that disk. So if I come here and do an insert, maybe let me just type here for the sake of, I do insert into TBL messages, then I come and say the ID is 1, the MSISDN is 254722000, the Safaricom number, and then we can come here and say test message. And then we can come and say created on is now, and then the created on, updated on, you give it null, and then status becomes 0, assuming that 0 is not processed, and that is okay. So I can come here and I can actually run this query here. So I'm assuming that you guys will be able to, into these values. I forgot to insert the values. I know some of you can see the error and you're like, I don't want to speak. Yeah, so you can see that. And if I come here and I change this, you can see, of course, the files are they work on frames. So there is a certain file size that has been allocated. Once you insert more records, you'll see this file size change it. So essentially, I've demonstrated to you that actually databases store data on disk. And I've also demonstrated how to create a table. And I've shown you how to use show tables. I've shown you how to use a database. So if you want to use another database, so you can say all databases that are there, show, and then you can decide to change to group 9. And I can go to group 9 and I can show tables that are there. This is my SQL stuff, and I can see group 9 members. If I do group 9, I will also teach you another command, which is on our notes, group 9 members, and I can do that. It will give me the table, how it was created, the structure of it. But if I want to see the SQL statement that they used, I can say show group 9 members. So you can see, so if I was not part of the group 9 team and I wanted to come and recreate the table, I can come here, copy, and I can come and create it in another DB. So essentially, I've just demonstrated to you a few commands: show tables, describe a table, show how the table was created, and another thing which will be very, very important in operations. I told you earlier that I'm sharing what I think you should not ignore when you're dealing with databases. Whether you're dealing with Oracle, find the equivalent. Whether you're dealing with something else, find the equivalent. It's another thing. You can run a query and it takes so long for reasons that we will explain later. One of the key things to know is you can actually use show process list in one word, and these commands are there, and it will show you the guys who are connected. So you can see that all connections are localhost. Is there any query that is running? So you can see here, it was in the query that was running. If a query runs and takes too long, you'll see it here and this is in seconds. So you can actually see a query. And once you run that query, you discover it's taking too long, and you can actually come and kill that query. Another command that I will show you. And we have killed there. And if I do show process list, process number 9 has disappeared. Again, this comes at a very timely moment because you understand now processes from an OS perspective, and you can see how even Docker containers, they adopted the word PS because they're thinking of containers as processes. Even in databases, when you talk about the queries you are running, there are also processes that are being managed by the DB. Sometimes show process list does not show you all the information. You could say show full process list. This is something that you need to know, especially when you hear that, hey, our system is too slow. the first thing we come and do is to try and show the process list. Then we discover, yeah, there is a guy who is running a query that is dumping data and locking the table and affecting the users. And what do? You kill the process. Of course, you'll kill the process if you know for sure that that process, killing it, does not crash something. So it's always good to know which queries are running and whether you can kill them or not. So I've shown you how to kill. Now, one of the things that I will show you is, let's say, for example, you can do select star, which DB am I in? So I can say show tables. Okay, we have not selected the DB. So let me select messaging. If you don't know the DBs that are in place, you can actually show databases and it will show you. And then I can select. Once I'm inside the DB, I can show tables. And once I show the tables, it shows me the tables that are here. I can do select from TBL messages. And once I select, I can see the insert that we did. And let's say, for example, if you want to run a query and you don't know whether it will take a lot of time, you can use the word explain. And this is very important in operations. Please take note and watch for opportunities where you will run these queries. And explain tells you whether the record, the query will take a lot of time or not. If you write a query that selects 4 billion records in a DB, definitely it will take a lot of time. So the rows that you're selecting will be indicated there. If you see the rows are too many, just know that the query will take time. So this is a precautionary thing that you can do before you run any query statements on the server. So this is something that you might need to reference. And then the other thing that I could tell you is that you can actually do another nice thing to copy a table structure. Let's say, for example, you want to create another table. So you can say create table. These are tools that have been very, very important in my life, and I hope that they can also help you. So I'll come and create a new table, and I call it messages 2. And you say like the first table. These are quick hacks that you need to know. Whether you're dealing with Oracle or MySQL, you need to know. If I now come and do show tables, I'll be able to see 2. If I describe the first table and I describe the second table, I'm able to see that they have the same data. But if I select and I select, the second one doesn't have data. So the create table just copies the structure. It doesn't copy the data. And if you want to be sure that that table actually exists, you can go to the backend and you can see where this is. Now, why am I showing you this? Because sometimes when you install, you might want to change this directory to go to another volume that is probably on RAID. Maybe you have high redundancy or volume that you can detach that is not attached to this server. So sometimes you need to know about this folder, because if you want to migrate data, you need to go and map a new directory and you copy all the data that is from here to there. And now you go change the configuration file and you restart the service. If you didn't know this information, then that explanation would be very difficult for some of you. Now, there is also another command that you can rename a table. So let's rename table 2 and we rename it to table 3. Let me just come here and I rename this to table 3. Sorry, or did I just rename table 2? Sorry, I forgot the word 2. So this one will actually rename the table to another table name, another hack that you need to know. And if you do so, did I just rename? Rename table. Just like the way you say create table. Yeah, so that's it. And if I show tables, this is it. Now, these commands are very necessary because sometimes you guys are used to accessing database through some workbench or another SQL tool. When you're dealing with live operation of servers, sometimes you have zero access to those tools. And these commands become very, very critical for you. And the other one, if you want to copy the data now that you had in the first table, so I can come and say insert into. First, before I do insert, let me just come and select so that you see that table 3 has nothing and table has something. So I want to insert into the second table, table 3. And then I can come and allow me just to insert another record into the DB so that I demonstrate that you can actually copy a few records and insert into this table. So I can come and say this too. And I can put these as, let's say, for example, this one was processed. One was processed and the, so let me just insert this and then I mark one as processed and then I can demonstrate what I want to do. So before I copy, I will come here and do another insert. Okay, the primary key must be unique. So I have to come and change this to 2. If you have any query, please post them on the chat and you can see the 2 messages are there. So let's assume that our system processed the first message and then I update this table set updated on to now. Mysql supports now. If you go to Oracle, you might find and, so you don't need to do and, you do say comma status and you say maybe status is 1, meaning that it has been processed successfully, where ID is equals to 1. Now that updates 1 record and I can come here and select and confirm that. Let's assume that the system has 1 billion records, but the system is too slow, but these billion records, many of them, 99% of them have already been processed. And the system is slow because of data that is historical. So you want to create a new table that looks like the current table and you copy the messages that are not updated. So you can actually come here and you say, I want, before I do so, let me just insert into 3 here. Select messages, 3 here. You can see that messages has data, messages 3 has no data. So we are assuming that we are in a crisis. And in that crisis, we have discovered that we need to move messages that are not processed. Maybe you have stopped the service and you want to insert this. So you select star from TBL messages where status is 0, meaning that they have not been processed. And what you will do is by doing so, it's going to copy the data. Now, if I come here and select this table, this current table, you see it has 2 records, but the new table which we have inserted only the active messages, you can see it are the unprocessed messages. You can see that it has that message in place. So this is another thing that you could have. And if, let's say, for example, after you do that, now you want to back up this, you can rename the live table, TBL messages, to, sorry, I forgot to put the word table here. Some of these commands, you run them, you put them into a small, then you can say TBL and you say backup and you say the date you backed up, 2022, 10th, 6, and you can say that. And now after you rename that, if you show tables, you realize there is no TBL messages. So we rename 3, TBL messages 3, and we rename it to TBL messages. And here I come and say 2. And I also come here and say rename table. Yeah, and then I show tables. Now, essentially, if you want to become, now you can see the table is there. And if we select, you'll discover that the new table has only 1 record. So if you're considering that this was a crisis you are managing, and I'm sharing this because I have done it many times. I've been found in a situation where the table has so many records and you don't need them and you have a MySQL DB. This is how you do it. Now, the other alternative is to now look for the other DB systems that you're dealing with, and you just have to figure out how to do the equivalent on that. DB. I don't know whether there is anyone with a question up to now, because I want now to move to the last part, which will be important concepts within databases that you must know. Alvin, you're asking, yes, is there a way to reset my SQL password in case you have forgotten? There is, but I don't want to, those are some of the things that I also just Google. But you can change the password once you log in. If you have forgotten the root password, there is also another way of dealing with it. Yes, it's possible. Primary key can't be automatic, as in it picks without doing it. So Maranga, you're saying, I don't know whether I get your question. Maranga, do you want to clarify your question?
Is it possible, like my question was, is it possible for primary key to be automated, like without just putting it directly? Like the
Yes.
doing 1, 2, so you just pick it automatically.
Yes. When you're creating the table, if I come here and create table 5 and I call it maybe table 2 now, and I come here and I say, I think it's auto increment. I don't know whether it's one word or that one. Let's just run it and then we see whether it works. Yes, you can do that. And I want to come and create a table. I think it's auto. So I think I just changed the order. So I can come here and say not null, and I say auto increment, then I pass primary key. I think it will work. It was just the order. So let's see. It was auto increment, but I was writing it at the wrong place. And I believe this should work. Yeah. Show tables. So if I do an insert now into this table without specifying this value, but now unfortunately, if I do that, I need to specify the columns. The other one I was able to insert without specifying the columns. So here I can come and say into this table, you specify the columns. The first column is MSSDN. And then the second one is content. And then the third one is created on. And the fourth one is last updated on. And the last one is status. So if I come here and insert, and I can insert, ID doesn't have a default value. Why? This is message 2, table 2. Sorry. Table, you see now table 1 tells you that ID doesn't have a default value. This one will just insert. If I insert many times, it will insert correctly. And if I select star from TBL messages, then I'm able to messages 2. Where? Yes, I'm able to see that the auto increment was given a number. Each of the thing was given a number, and you can see the status is 1 because I inserted 1 erroneously. I should have inserted as 0. Yes, so there are those things that you will deal with in operation. Then, Mr. Wakungu, you're asking whether you will install MySQL locally. No need, but if you want to do local development with a local DB, you can, but I would recommend that if you want to develop locally and connect to the DB, you can install, but you can actually run these commands on the server. I do not have MySQL on this local laptop. If I come here and I run MySQL, I don't have any command. I have not installed, yet I'm running the commands on the server. Yeah, so for the challenge, you don't, but maybe at the point of development, you might find it necessary to test on your local DB, although sometimes you could have profiles and connect to a remote DB so that guys can operate from the same DB. That's what we do at work. People don't have to copy the DB. You have the development DBs on a certain server. Then when you're developing, you just connect to that DB remotely. So I hope that's okay, guys. Can I proceed to the last part that talks about now key concepts that you need to understand? This will be theoretical, but I hope that my explanation will help you. If you need us to dive deeper into one of the concepts in a later session, I'm willing to help, but this is dependent on you. But of course, you have also a lot of information online that you can use to study these concepts, but do not forget them. So I hope I can proceed. Maybe I can get some confirmation from the team. What is the difference between primary key and primary key and unique constraint? Now, unique means that the primary key is, and sorry, maybe Anne, just allow me to talk about indexing, and then we can talk about unique. Unique basically constraint means that in that column, you cannot have two values. Like if you have a user, you could have an ID in the table, but the username must always be unique. So the ID is always unique, but a unique column does not necessarily have to be the primary key. Now, one of the things that you'll notice, whether you create something unique or whether you create an index, there is something that we call indexing that helps us in optimizing the system. So there is something that I'm going to show you, Anne, as we continue. I hope that by the end of the day, I will answer your question. But the answer is a unique column does not necessarily need to be a primary key. But a primary key expects unique values. So even if you don't say unique constraint, you will still need to, it will still require you to insert a unique value. Like you can see what we did there. I tried to insert another record with ID 2, and of course it gave an error. Let me just see whether I have the query here. Yeah, so I tried to insert this record here. And I can come here and say ID 1. And we all know that ID 2. And then I can come here and I can say ID. We all know that, you see, you can't have a duplicate because the primary key cannot take duplicate keys. But if you want a column that's not a primary key to be unique, you just add a unique constraint. I hope I've answered you, Anne.
Yes, you have.
Okay. Now, some of you might have heard about indexing partitioning. Anyone who doesn't know what is indexing or partitioning? Those who have heard indexing, partitioning, please confirm on the chat, because that's now the next thing I need to tell you. If you build systems just to show you a lecturer, you might not have gotten to the need of indexing. If you're building systems to run in a production environment, then you have to know these concepts. I can see that there are people who have not heard. Okay, I'm in the right forum. All the guys who have, there is one person who has heard about them. So allow me just to continue because I can see partitioning is foreign to you. Even by the time you leave here, I hope that you will say that you know what indexing is from a theoretical perspective, and you can also practice the indexing on your own. Now, I do not have a better way of explaining indexing than to show you this image. Anyone who has ever seen something like this in a book? Seen an index in a book? Yes, Alvin, I can see. Wakungo, I can see. Steve, thank you so much. So this is called an index, and whatever problem it solves is the same problem we are trying to solve in databases. Now, an index, and I will also borrow another cousin of an index called the table of content. Without table of content, some of you might have never read the Bible, because imagine being told to go and find where Moses and the burning bush, that incident was happening. You might never find in many, many pages of the Bible, or even your schoolwork, you might never know where the content, the definition of isotope or atoms in chemistry, book 2 or book 1, you have no idea where to find it. But because of indexing, and I will borrow the brother table of content, those things solve one thing, that it's very easy for you to locate content because you narrow down to a few pages where you can select the data. This indexing will not make sense if you do not understand the first concept that I told you, that data is stored in disks. Now, if you have a table that has millions and millions of records, the day you select from that table, and you're selecting where MSISDN is Anne's mobile number, and you want to see messages that have been sent to Anne, what happens is that the DBMS comes to the disk and searches for this file and checks each and every row, each and every row, each and every row. It's like being told to go to the Bible and look for the story where Paul wrote a letter to the Philippians, and you're starting now page by page trying to see where it is. It's very exhaustive, and it will take a lot of time, wastage of resources, your time, and on the server, it's wastage of the CPU and the precious time that you need to do other things. And because of that, when you create an index, what happens is that the index, you must specify the column that you want to use. So if you create a primary key, the system always creates an index for us. And that index is a table of content that is stored in memory by the DBMS. And this is what makes a huge difference. So the index is stored in memory by MySQL. And that's why when you're setting up MySQL, you have to give it memory. And you can do optimization by giving it more memory so that it can have more space to store data in memory. If you're searching for something exhaustively, even if you have 30 million records in memory, it is super fast. Doing the same search on disk is too slow because I/O is still the slowest element of computing. When you're going to either disk or the network, it's still slow. Even with advancement of technology with SSD, solid state devices, those disks that are super fast, it is still super slow in relation to memory. So what happens, or in relation to the speeds of the CPU and how memory can perform? So what happens in indexing is you create a thing that will store a reference. Let's say, for example, in a table that has 30 million records, assume Anne has only 30 messages in that table. If we index that table by the mobile number, it means that in memory, we will store a place where we will say, Anne's number, instead of the word archive, Anne's number, go to page 12789. And what means is that even though the book, which is our file, has 30 million pages, if you're looking for Anne, you don't have to scan through the 30 million pages. You just scan a few pages that are given by the index. And you'll go there and, trust you me, searching 10 pages that contain Anne's information is super, super fast. So you can see the impact of indexing in databases. So if you're told to index your table by this column, then it's because we know that by the time we're querying data, that column will be a common column for where. Like if you're looking for someone's balance in the core banking system, maybe there is an account number column. If you're selecting so much with that column, then you'd rather create an index on that column so that we can maintain an index, a table of content, and where that account number is, we can tell you which records in the disk we are supposed to go and pick. So instead of scanning, moving the disk head, if you're using magnetic devices, if you're moving the head of the disk from up to the bottom of the file, you just now skip a few pages and go to page number 7. Then you go all the way to page 20 million and 17. Then you go to page 30 million and 1. And you get those 3 records, you return them, and the query will be super fast. I know in this session, I didn't have a lot of time and I didn't have data to show you, but maybe one day, if you guys are interested, we can organize a session where I'll put a lot of records in a table. We run a few queries. We see how slow the queries will be, and we see how we create an index. And once we create the index, we see how fast the queries will be. And what considerations must you make to do the indexing? So today, my work is not to make you an expert in indexing, but it's just to point you to what problem indexing tries to solve, so that now you can dive deeper and learn more. So I've explained all these things. I don't need to repeat them. A database index is another object that you store in DB, normally stored in memory, unlike the tables which are stored in disk. And they are used for quickly locating data when you want to retrieve data. By scanning the index, you figure out which rows to go to the disk and pick. So you don't go and scan all the disk rows, you just scan a few rows because the index helped you to identify that location. Now, how queries are executed in a DBMS if there is an index, the moment you write select, it goes to something called the query analyzer and optimizer. They could have different names depending on the DBMS system that you are dealing with. Tries to see that you guys are merging two tables and you're writing your SQL in a very bad way, rewrites the query for you, and that's now query optimization and all that. And then after that, identifies if this query will use a certain index. If there is an index that matches the query, we just go to that index and find the records we need to get. And sometimes when you're using a DBMS, you can run a query the first time, it is super slow. You run the second time, it is slow. It is super fast because of caching. So there is a policy of storing some records in memory. Although your data in disk could be 3 GB, the DBMS can store data for like 300 MB of data in memory, so that if you select a record and it was selected by someone previously, you go and pick it from memory and you return. And for those guys who have heard about commit, it is in relation to storing data in the cache before we persist on the disk. So sometimes you might find data in the cache, or sometimes you don't find it in the cache and you go to the disk. But once you get it from the disk, you store it in the cache so that if someone runs the same query a few seconds later, we can have it. Of course, you can't store everything in the cache, so the DBMS has a way of cleaning up old records that are not being used so that the memory is optimized. And in the event a record is removed out of memory and you ask for it, we go to the disk, get it, cache it again, and the process continues. If you don't have an index, just know you'll go to the disk and you'll scan all the records, and it will be like reading the Bible from page 1 to the last page, looking for Revelation chapter 3. And it is super slow. Add table of content and everyone in a class will actually get to Revelation chapter 3 in a few seconds. But if you don't have index table of content and the students don't know how the content is organized, they'll start from Genesis all the way to Revelation looking for that chapter. So that's what indexing does to you. If you read books, then you understand. Primary keys is an index, or the primary key is an index by default. So you don't have to create another index. You'll always find that it is there. And indexing improves your select, but it has an impact to your update. If you had a chapter on atom and you decide to add another page on the chapter of atom, it means you have to go and update the table of content afresh. Because page 13, which was the last page on atoms, and you added page 14 on atoms, then page 14 used to be in another chapter in chemistry. And now you have to shift every page. Now you give it you +1. And after you +1, what do? You update the indexing. So chapters, numbers in books, they are helping our element of indexing to ensure that we get data fast. So indexing is part of the database and part of query optimizations to ensure that your DB responds as fast as possible. And because we are creating systems that will be real, we cannot ignore this fact. I hope if you have gotten what indexing is and you are ready to dive deeper and practice this thing, please you can comment on chat as I prepare to go to the next section, which is partitioning. If you have a query, please post it on chat and I'll address it. Indexing, are you okay? We say yes and we proceed. Anyone who now indexing, they understand what problem we are solving on indexing, you can confirm on chat. Thank you guys. At least I know that the session was useful because I can see a good number of you have understood what indexing is. Now, in the same spirit, partitioning in books, and I use the analogy of 844 system, which we are trashing to adopt a new system called CBC. But I'm a student of 844. And let me give you a hypothetical scenario that never existed. Assume that all the content in the whole 844 curriculum was in one book, meaning that when you are being told 1 plus a box is equals to 3 in grade 2 or class 1 or 2, there is a page with that. And at the same time, there is another page with, for those of you who did computer science, there is another page with Rungekuta iteration methods, numerical methods, and scientific computing. All those pages are in one big book. How easy would it be for you guys to retrieve the data? I agree with you that it is very, very complex for you to discover Moses and the burning bush in CRE, in Form 2, in that book. Basically, if you tell someone to open the page on atoms, they'll spend years before they figure out where that page is. Now, you can bring the concept of indexing and you make work easier. But then when you're going to class, you'll be carrying a big book and you know where to allocate the data. And table of content alone is about 600 pages. And now that becomes something very, very difficult. So what we need to do is the concept of partitioning is what you have learned in 844, and it works. If you want to retrieve anything on Atoms Book 2, the books have been partitioned, or the content of 844 systems has been partitioned using 3 parameters. The level of education, whether you're primary, secondary, or tertiary university. Then they go ahead and split it or partition the content again based on the level or the grade. So if you're in class 1, 2, 3, 4, then they realize there is no need in having one book called Book 1 that has chemistry, CRE, and everything. So they went ahead and decided, although Book 1 for, a book that has all the subjects looks nice, but can we also partition based on subjects? And that brought us to where we are today. Is it useful? Yes. Partitioning is also very, very useful in DB because it can help us focus on selecting data where we want. So I've given a table here. You could be having a system that records transactions or orders every month. Now, you could be receiving billions of orders every single month. So what you could do, you could decide to partition per month, and you just have records for the month of January in one partition, same table, and the records of Feb in another partition, same table, and March partition, same table, all the way to December partition, same table. What the DBMS does, and I'll use MySQL DB engine to just explain that what DBMS does, if you partition this table called TBL messages, instead of seeing one file called the table name.ibd, you actually find the table name, hash, then the partition name. And every partition is mapped into a specific file on the disk. How does it benefit us? It benefits us because when the system is live and running in the month of October, we can actually do manipulation, do a lot of queries in the other partition without affecting queries that are live today. So you could think of partitioning as a strategy to help you reduce the data in one file, as long as your queries, they are always within the context of, you'll know which partition. Because you don't partition, then you end up searching for data in all partitions. So it's always good to know that partitions can also be used for optimization. They ensure that we now have smaller files instead of one big file. Indexing allows us to put the table of content, but partitioning allows us to split the big file into small files. And if you really think about it keenly, with these, we are able to actually optimize our DB. And in terms of operations, you can actually have partitions for yesterday. And if you don't need yesterday's data, you can actually delete the data or even drop the partition without affecting today's partition, without even causing a split of a second effect to the live traffic that is happening on the live partition. So if some of you want to archive data real time during the day when system has, 1,000 inserts per second, you can actually do that and you archive the old partition. So you can consider these as a thing that you can use in your DB optimization. So in other words, what I'm saying is that partitioning allows tables and indexes to be organized in subdivided smaller chunks, enabling these database objects to be accessed and managed in at a finer granular level. In other words, if your table has 100 users, do not partition, do not index. It's a waste of time. 100 users for us, 100 records in a DB, super fast. But if you know that this table that I'm creating will have millions and millions of records being inserted every single day, and people will be querying that table live as the system is inserting and people are querying other things, then at that particular point, stop a bit and think about how you can optimize partition by partitioning and indexing. So I hope I've made sense. Again, as I said, we might have another session where we can actually do live indexing and partitioning. As I said, today is just to help you understand that these things do exist and they have a place in the space of engineering, and they actually solve a real problem. And if you don't believe it, you are the candidate for the next session so that you actually see the impact of partitioning and indexing. Yes, Tevin, you're right. Indexing is like creating the table of content for a database table. Not database, it's for a database table or a collection if you talk about the NoSQL guys. The database is the folder. This is the database, Tevin. So this messaging is the database. So the tables are the ones that store the records, and those tables need to be indexed. I hope by now you see why I started with telling you files and records being put in files, because without that knowledge, or with you assuming that magic happens behind the scenes, it will be difficult for you to understand partitioning and indexing and what problem you are trying to solve. So it's the disk, the partitions are split, and you have a file for each of them, and this is a good example. So of course, partitioning has a bad effect. Again, just like inserting, first before you insert, you have to discover which partition are we supposed to push this data to. And that, even though it is small delay, it's still a delay. So you also need to appreciate it's very insignificant when you're dealing with some of these systems. But the benefit of partitioning and indexing is higher than the cost of partitioning and indexing. Now, lastly, I want to tell you guys about connection pooling. Not lastly, really. If I tell you lastly, I'll tell you about many lasts. And I don't want to be a liar. So when you're connecting to a DB, the moment I come here and I log into the DB, and I do show process lists. Now, this shows me the connections that are here in the DB. If some of you are to connect to this DB remotely, your IP would appear here on the host, and your DB would appear here. I don't know whether I have a DB that I can use now to just test that, and I hope you guys will not abuse my server. But let me just show you a good example. Sudosu is changing from a normal user to a super user. And I want to come here and do my SQL. Okay, then I come here and I do show process list. And one of the things you'll notice that there are actually 248 connections to the DB coming from localhost, but there is also another guy called Mulika connecting to this DB to do 1 or 2, 3 things. You can see there are no pending queries. If there was a pending query, you would see it here. So if you have a very slow query, you would see it here. So this DB is basically very idle. Not really idle, but it means that the queries are being executed very fast. And the user who is logging in is called this UCM. Now, this is connections. Now, this UCM that you're seeing here, it's actually a Java application that is maintaining about, if you do the count, you'll be able to come here and, oh, by the way, yesterday I didn't show you something. Guys, you can actually come here and you say echo show process list. I know yesterday I didn't show you guys in piping. Echo show process list, then I give that, and then I do a pipe and I say my SQL. And it can get into my SQL and read for me that. Then I can grep UCM. I can see that, and I can also do word count minus L. In other words, there are 217 connections coming from UCM, And maybe what I can do is UCM, then I ensure that I have local host, because the Java application that is connecting here is actually, so you can see 211 connections connecting to this DB, and they have no query that is running, because you can see here there is no, they are all sleeping. They are waiting for data to come. And these connections, they are 211. And they are 211 because the application has been able to maintain connection pool. And that's what we are calling connection pooling. Now, connection pooling is where we do not, I know some of you might have learned about PHP or something where you know you want to connect, you ask for a database connection, you initiate a connection and you get a connection, use it to execute a query, and then you close the connection, or you leave it open and you reuse it, which we don't advise. Now you can imagine if you have a website that is receiving hits to the DB, and every time you visit that page, we connect to the DB and query. And of course, a DB, irrespective of what DB you create, they are limited. And especially if you're using with SQL based. Achana na hizi NoSQL. The NoSQL ones, sometimes they have, like Cassandra, you can scale, they are suitable for horizontal scaling. The old DBs, they are meant for vertical scaling. You increase the server capacity to ensure that you can handle more, allocate more resources. But these are the ones, they do horizontal. You can add many, many containers or hosts that work in that cluster, and you're able to achieve a lot. But nevertheless, connections are resources that you should use wisely. So if you have a website where someone hits that page and you connect to the DB, now one day your DB will crash. Why? Because if everyone comes and you have 1 million guys hitting the page at the same time, what happens? Your DB receives 1 million requests and it is overwhelmed and it crashes. Now, what you do is you tell the application that connects to the DB to maintain a connection pool, a pool of connections that are maybe 100 connections max, so that even if 1 million guys come, the application is able to hold the 1 million guys until a connection is available, meaning that your application will have too much weight, but the DB will be protected. And since the DB is a very important element of most of the applications, then you have achieved something nice. Second benefit, so you ask for a connection, and once you finish, you return it. And the connection pooling library, if you close a connection and you are told that we need to have a maximum of 100, minimum 30, when the connection pooling library opens up, it starts the 30 connections. And in the event that traffic increases, it maintains more, up to a maximum of 100 connections. And if they hit a maximum, it cannot go beyond that. So the application or the guys who are waiting for connections are inconvenienced, but you protect the DB. Now, connection pooling also allows us to achieve something. And I know here I'll confuse some of you a bit. But when you talk about ports, we talked about ports in the context of services yesterday, and we say MySQL opens 3306. But we also talk about ports in the context of OSI model, TCP/IP, at the transport layer, where we say the source port and the destination port. Now, these ports, if some of you could jog your memory a bit, when you're learning about OSI, when you're talking about ports, you're either talking about a protocol called TCP or UDP or SCTP, if you are a really advanced guy. And what we know about those protocols, especially TCP, which DB services use for reliable connections, MySQL uses TCP, is that before you establish a connection, TCP is connection oriented. Before you establish a connection to the DB, you, the client host, must handshake with the server. And a handshake is something that involves exchanging packets on the network. 3 of them. You do sync, you get sync ACK, and finally you get ACK. As you're doing that, maybe your application is running in Europe and your database is running in another cloud in another data center. The latency or the network weight will waste your connections. Now, another benefit of connection pooling is by the time the application is asking for a connection, that connection has already been prepared by the engine, the connection pooling library. And what you need to do is you'll get the connection and execute the query without doing handshake, because the handshake was done for you before you got the connection. So you're basically getting a ready connection to use, as opposed to the other alternative without connection pooling. When you need a connection, we connect, we give you. And that we connect wastes a lot of milliseconds. So if you want to see faster inserts, faster, all those things, then connection pooling becomes very critical. In enterprise systems, we use connection pooling. So you cannot avoid that. Otherwise, your systems will be crashing every now and then. When there is an increase in traffic, guys will be like, my DB crashed. We have run DBs that have been running up. And I mean, irrespective of the spikes, the DBs have been running for years without anyone needing to restart because of such concepts. So connection pooling is a cache of database connections maintained so that the connections can be reused when feature requests are made. Establishing a new connection every time you want to access the database is very costly because of the handshake, the TCP handshake. When application needs a connection, ask for it. It will be disadvantageous to connect every time and send the data. So instead, we maintain the pool of ready connections, and you ask for it, we give you an object, you write, you insert, select, delete, then you can close the connection or you can return it. So some applications close. If the reuse is a difficult thing, some applications just return and it can be reused. So when you open a connection to a DB, the first thing that happens is a TCP handshake. Then you are authenticated, because when you're connecting to the DB, username and password, and then you select the DB, then you read or write if you want to read, and then you close the connection. The handshake and the authentication step, and even selecting the DB, they are costly. You can avoid them if you use connection pooling. I hope by now you guys know what connection pooling is all about. You know indexing, you know partitioning, and you know connection pooling. And I do not expect you guys to create systems in 2 weeks that do not use connection pooling. We have many people who have used those things. They can teach you and they can show you. And that system that you launch, it will be a system ready to be used by the world, irrespective of how many guys come to that site. Your DB is safe and secure. So I don't know whether there is anyone with a question, and I will now have 2 more things to explain, and those ones will not take a lot of time, but I wanted to know whether there is anyone with a question regarding connection pooling, regarding partitioning, and regarding indexing. Very important database concepts. They are not MySQL concepts. They are general DBMS concepts. So whether you're doing Oracle, MongoDB, these questions still remain. So any question on the chat? So Ali, can I exit to optimization and migrations, and then we can call it a day? I will just touch on database replication and backups slightly, but it's something that we can look at later. Can I proceed? Thank you. And now optimization is nothing. I have just touched on some few strategies we use to optimize. So optimization is a strategy of reducing the database system response time. You select a record, it takes 40 seconds. There we bring in the concepts of optimization. I've already talked about a few that are very common and you must consider in your applications, but sometimes we do indexing, sometimes we do partitioning, sometimes we adjust the memory. You could be having a 30 GB RAM server and you have given MySQL or Oracle only 1 GB. And you're wondering why the Oracle system is too slow and yet the utilization of memory is only 10%. It's because you gave it a configuration of 10 GB for RAM. Whether they call it, it's just the caching, the place where we store records for faster response. If you run a query the first time, it can be slow, but a few milliseconds later, It is fast because of the concept of caching. Memory becomes a very critical resource in optimization. The other thing is, as I said earlier, that when you are writing data, your application is inserting, it actually goes, and I don't know whether I have a diagram that I didn't do a diagram. Maybe I should do that in future. But I just wanted to show that when you do an insert, you basically speak to the DBMS, and the DBMS gets the query, does the processing, picks the data, prepares the record to be inserted. It does not go to the disk immediately. It actually puts it into memory. And once it puts that query into memory, it later sends the data to the disk. And sometimes you hear you are flashing the data to disk. Other people use the word commit. And that means if you run a query without committing, it means that that record will basically remain in memory. When you commit, that's when it is pushed into the disk. And I know some of you have learned about, relational database management systems, or those SQL that databases that use tables and, columns and all that. Sometimes you talk about those commit concepts, and, you can do you can basically insert and commit. You can set auto commit. All those auto commit, they're basically configurations around whether you want to get a confirmation that the insert was successful after writing to disk or before writing to disk. And of course, all of us can guess. If you send the data to the database management system, which is a software running on port 3306 in this case, and you tell it to store the data in memory and acknowledge to you, it is much faster than waiting for the same application to acknowledge writing the data into the disk and respond to you. So depending on how you set the DB, you can have different performance. And at times, it can also risk the data that you have. So you need to be careful when you're setting those parameters, especially the commit, flashing data to disk strategies to ensure that you don't lose data. If your system is a system that if you lose one record, it doesn't kill anyone, then you can actually set lazy approaches of ensuring that you don't have to wait for the disk, because if you do so, you can improve the DB performance from maybe 5 inserts per second or 50 inserts or 200 inserts per second to 1,000 inserts, which gives you a better performance in terms of how much you can actually handle. And you have to do calculated mathematics. You have to do calculated decisions to ensure that you don't risk something. If you're dealing with a financial system, avoid anything that you think could lead to a loss of a record. Yes. So migrations, and now I am borrowing from what we had. I think 2 days ago, one guy called Peter Kiptanui took us into the world of DevSecOps. And I know some of you might have noted one thing, that the culture they are trying to promote is where you don't do anything manually. You just write code, you push your feature branch, it is merged into develop, and then later you have a UAT, a release is being done. And once the release is up and everyone has tested the UATs are okay, we merge into the master or the main branch. Once we merge into the master or the main branch, that activity of merging alone triggers another thing, maybe through a webhook to Jenkins, and Jenkins goes and builds the images, pushes the images to Docker Hub. And once the images have been pushed to Docker Hub, somehow, containers are brought down and brought up with a new release, and customers start enjoying the new service. Now, if you're doing that, and in your release, you just added one column in your database table, if you're using an SQL database, that means that automation might not be practical, because someone has to do a manual activity to upgrade the DB before you move on. So migrations in relation to DBs is actually just think of versioning and tracking your DB changes and applying the changes automatically as part of what we learned in the DevSecOps operation. So DB is the weakest link, especially if you're using SQL databases. No SQL databases, they save you a bit because they are not too strict on the structure of the collections. So I can create Agnes as a person within my collection. I think of a table if you're not familiar with NoSQL databases. And that record or that document that we add there, that is Agnes, could have attributes name, age, date of birth, name, date of birth, XYZ. And then I decide to add another record called Anne, or another document called Anne. And that document has 7 attributes of that person, while Agnes has 6 attributes of that person. If you're using SQL, you have to change the table structure to accept the 7th column. But if you're using NoSQL, you don't need to do that. So in the event you're using SQL, then you need to monitor those changes, and you can actually do that. Peter was the one who came up with this part of, actually, he just nominated the article. I just put Liquibase as one of them, but even Spring JPA, they have their own way of doing migrations for those guys who are doing Spring Boot and stuff like that. There are many tools that help you to say that, yes, I'm changing this object now has a new field. The student object has a new field called the year of graduation, which was not there in the initial version of the system. And because it has a new field, then you have to go and change the DB to have a new column. Now, instead of changing the DB manually by writing an SQL statement and update it manually, you also use a library that can track changes, and you tell them, I have a change set and I need to change this thing, and this is what will happen. So it's a structured way of saying, in this release, ensure that you add this column to this table, and the migration libraries will take care of it. So when you start the application, before it does startup, the migration script checks whether there are any changes that need to be effected. And if they are there, they're effected, and then the application is started. And that way, you will have to do full automation of deployment without having to do manual updates to the DB. And this is because the DB was one of the weakest links as far as this automation and creation of images and doing everything that you do was concerned. So, and finally, I'll just mention briefly on database replication and backups. And the basic idea is, if our database is here, it's very unsafe for you to have a DB, because if a hacker comes in one place, if a hacker comes in, things can go wrong if the DB is deleted. So some of the strategies in MySQL for doing that, and if I go to the data directory or the data path, as they call it, you can see something called here binary logs. Binary logs ensure that they keep a record of everything that you do. You can see this one was, server is running. It's running on a very funny time zone. It's 8 a.m., wherever this server is running from. But you can see that there is a binary log file that is active till 8:28, which is essentially maybe when the last update that was done on that DB. So essentially, every SQL statement that you insert, a copy is kept here. So what happens is, in MySQL, these binary logs can be shipped to another server, and they can be applied on that server, and you have another DB that looks the same like this one. So this is just a bit of what needs to happen. But what happens is, in replication, you ensure that you have one server that sends data to the other. If data is inserted here, we also ship that data to the other side, and you can insert. Backups, you can decide to take a whole DB backup. There is a command in MySQL called MySQL dump, or you can do incremental backups, where you actually do a full backup every Monday. But then from Monday till during the day, you ensure that you keep these binary logs. If the DB crashes or someone deletes it accidentally, we tell the business we are down, and we shut our services down. We sit down for a few hours. We take the last full backup, and then we come and pick the binary file or the incremental backups, and we apply them, and we get the DB as it was at 8:28 a.m. So this is something that you could think of. The idea of backing up is to ensure that you pick this data and you ship it. I know some of these things with managed databases, with these cloud providers, there are headaches that you don't need to worry. But who knows? One of you here could be the next founder of the cloud service provider in Kenya or in Africa. And these are concepts that you need to appreciate from our first principles. What actually happens? So in a nutshell, every insert you do is inserted into the folder here. But at the same time, you also write a record into that binary log file. As you can see, this binary log file is rotated. So we had 19, 20, 21, 22, 23. If you come tomorrow, you might find that we have gone to 23. And now once a file is rotated, you can ship it. And once you ship it, you can say you have a backup. Now, what inserts data into these folders and creates these files? It's a software that is called the manager of these DBs, and it's the DBMS. And I will finish there, and I want to know whether there is anyone with a question. But from today, please do not confuse what a DB is, what a DBMS is, how the DBs or DBMSs represent data in disk. Don't forget that fact. Sometimes data is in disk and it is cached into memory, and that's why sometimes DB could respond faster. You need to know indexing, table of content, partitioning books so that you can have smaller books that you can search. Even if you do the full scan of a book 1 chemistry, it's a very short period of time. But if you're told to look for book 1 content in a 844 book, then it becomes very difficult. Partitioning is very, very good. And it also allows you to do what you used to do when you're in high school. If you went to a school like mine, you used to do academic fires after finishing every level, meaning you're deleting the partitions that are not necessary. And now you go to the university and you get new books. Then after that, you can do another academic fire until you come and realize that the fire was not relevant and you should have kept the book and refer to them as you enjoy your life in this side of the universe. So that is it. And I hope I have brought those concepts to you and you are ready to dive deeper into these manenos of DBs, and you can now do a lot of stuff and you don't need those tools that you need to access the DB. You can actually practice a few commands here and there. So I will allow you guys to ask questions for about 5 minutes, and then I'll end the session and pass it over to Marlene. That was a long session, but I hope it was beneficial.